Hi, this is Miss Park. Today we're going to go through a buffet of factoring methods. So factoring is a concept that was covered in grade 10, and it has to do with, if you've watched the area models video, so you all should have watched the area models video before this, because I will be using area models here. We have covered already common factoring and factoring simple trinomials and factoring difference of squares. We did not yet cover complex trinomials. So we're going to do that here too. But this, I'm going to go through all of the different kinds of factoring right here. And so a little bit of review, but also maybe some examples that I didn't use in the area models video. So I'm going to start with common factoring. Okay. And the question in common factoring would look something like factor 12x plus 6. Okay, something like that. And remember that factor, the word factor, means to write the expression as something times something. Okay, so we want to write the expression as a product, something times something. If you've watched the area models video, then you'll understand that really what we're being told is, here's a rectangle with area 12x plus 6. What are the length and width? Okay, so try some numbers. So let me take out these question marks. So I could have a width of 1. Sorry, I could have a width of 2. Well, if I had a width of 1, then the other one is just 12x plus 6. So not really, it's not a really interesting product. So let me just take that out. To find a number that's a little more interesting. So how about a 2, right? A 2 will divide evenly into 12x. It'll also divide into the 6 with no remainders. So I know 2 is a common factor of 12x and 6. So I could do that, split this up. What does this dimension have to be? So 2 times 6x gives me 12x, and then 2 times 3 gives me 6. So I could write 12x plus 6 as 2 times 6x plus 3. Okay, 2, remember, is called a common factor. Okay, now there's another way I could write it, because if not 2, I could actually even pick a 3, because 3 will divide into 12x. It'll also divide into 6. So if I made it a 3, I could actually say, well, then that dimension must be 4x, and that dimension must be 2. So I could also write 12x plus 6 equals 3 times 4x plus 2. That's also factored, right? Both of these are factored. Now, to be fully factored, what I want is to find the greatest common factor, because what happens here, these ones are factored, but the bracket here, the binomial, can be factored further because there is a common factor between the 4x and the 2. This also, there's a common factor between the 6x and a 3. 3 is a common factor of this bracket. 2 is a common factor of this bracket. So that tells me I can go further. So is there a larger number that divides into both 12 and 6? Yes, there is. The largest number is 6. Okay, so if it's a 6, then the other dimensions would have to be, let's clean this up a little bit. The other dimensions would have to be 2x and 1. Okay, so now I can write 12x plus 6 equals 6 times 2x plus 1. And we said this is fully factored. Okay, and that largest possible factor you can take out has a name. This is called the GCF, or the greatest common factor. So when we do common factoring, greatest common factor. So when we do common factoring, we always want to find the greatest common factor, because that ensures that the other factor can't be factored further. All right, so there you go, common factoring. Let's go to the next one. So the next one is simple trinomial. Okay, so again with the area model, x squared, let's go plus 10x plus 24. I feel like we've had an example like this already, but that's fine. Okay, so using the area model, we're looking at let's fill in. The x squared will sit here, so that's an x times x. The constant term, the one without a variable, is going to sit here, so that's 24. We got to find two numbers that multiply to 24. Okay, so I know 3 and 8. The 3 and 8 will give me a 3 times x, which is 3x. 8 times x is 8x. When I add up all these terms, I'm going to have an 11x as the middle term. So I want to have a 10x as the middle term. So what do these two numbers have to be? So we'll try other things. What else multiplies to 24? 12 and 2. So I can try a 12 here and a 2 here, fill in these parts, add them up, and find out that it still doesn't add up to 10. So keep playing with it until eventually I realize, okay, 4 and 6 will work. So this is 4x and this is 6x. It adds up to the original. And so that is x squared plus 10x plus 24 can be factored as x plus 4 times x plus 6. Okay, that's factoring simple trinomial. Now, last year, if you didn't use area models, then you probably did this. You said, in order to factor this expression, I'm going to have to find two numbers that multiply to 24 and add to 10. Okay? Now, if you're still kind of stuck on this or trying to remember the rule, just remember why the two numbers that you pick multiply to 24, right, and add to 10. Right? That's exactly why. So the area model shows you why this rule applies. All right, let's go to now complex trinomial. So you'll recall that with simple trinomial, it's of the form ax squared plus bx plus c, where a is equal to 1. Okay, this a coefficient is 1. So in the complex trinomial, so remember trinomial means 3 terms. Okay, in the complex trinomial, you have ax squared plus bx plus c, but the a is not equal to 1. So there's something else over there. So let's take, for example, 2x squared plus 7x plus 3. All right, so I see this x squared term, and so here we go, area model version first, okay? I see the x squared term sitting here, so I know that's 2x squared. I see that 3 sitting there, so I know that that's a 3. All right, now these are going to be the terms of the x's that I got to check. Now, 2x squared, the only way to get it, I must have an x and an x to give me x squared. The only way to get 2 is 2 times 1. So whether I do 2 times 1 or 1 times 2, it doesn't matter. So this is a 1 right here. Okay. And now I'm just going to try to find numbers that multiply to 3. So 1 times 3 will do it. All right, so let's check. 2x times 1 is 2x. 3 times x is 3x. Add it all up, make sure it adds up to the original. And it doesn't add up to the original, right? It adds up to a 5x instead of a 7x. So I'm going to fix that and see what else I can do. And with these numbers, there's really not much else I can do because I picked numbers that don't have many combinations that multiply to them. So instead of 1 and 3, I'll just switch it up and go 3 and 1 and see if that helps. 3 times 2x is 6x. 1 times x is x. Add them all up, you do get the original. So I can factor it to be 2x plus 1 times x plus 3. All right, so that's how you would do it with an area model. So there is a little bit of guess and check inside here. All right, let's continue with complex trinomial and let's go, so I'm going to go complex trinomial, and we're going to call this the method of decomposition. Decomposition is a popular method of factoring. It's all algebraic, but it's kind of foolproof in that you follow the steps and you don't really have to guess and check. You don't have to try numbers and then go back and erase and try different numbers. So we're going to go with 2x squared plus 7x plus 3, and I'm going to show you. So if this is familiar to you, great. And if your teacher used different methods, then it won't be familiar. That's fine. Okay, so in the case of complex trinomials, Remember with simple trinomials, when there was no 2, we found two numbers that multiplied to the constant term and added to the middle term. Right, where are we? Two numbers that multiply to the constant term and add to the middle term. Okay, so let's go here. With complex trinomials, so it's again ax squared plus bx plus c, you want to find two numbers that multiply to not c, not that last term, but ac. Multiply to AC and add to B, which is the middle term. So we want to find two numbers that multiply to AC. So multiply to 6 and add to 7. So what two numbers multiply to 6 and add to 7? So let's check. So 6 can be written as 1 and 6, so 1 times 6. It could also be 2 and 3, so 2 times 3. And that's it. Those are all the combinations, because 3 times 2 and 6 times 1 is already the same as this. So which one of these combinations adds up to 7? It's this first one. So I'm going to take the 7x and I'm going to decompose it. Break it down to two parts, the 1 and the 6. So I'll take my 2x squared plus 7x plus 3 and write it as 2x squared plus 1x plus 6x plus 3. All I did is I decomposed the 7x into x and 6x. That's from here. All right. And then what I do is I'm going to take these four terms and I'm going to common factor them. Okay, so this is called factor by grouping. I'm going to actually write here. Factor by grouping. It is common factoring in two places. So I'm going to common factor this first part. Get rid of this. Okay. Of the first two terms, is there a common factor? Something that divides into 2x squared and into x? So from the numbers, no, because that's a 2 and that's a 1. There's no number that divides into 2 and into 1 except for just 1. So they both have an x. So my common factor is an x. I will factor it out. And what's going to go on the inside over here is what I'm going to get when I take my expression and divide it by this x. Right? Remember, factoring, you're given the product and you have to write it as something times something. So if you know one of the somethings, then to get the other one, you take the product divided by the first one. So 2x squared divided by x leaves me with just 2x. And x divided by x leaves me with 1. Right? I'm going to common factor the second group now as well. So what number or what term will divide into both of them, and it should be the greatest common factor. So the greatest common factor from these two terms is the 3. And I'm going to have, so take this expression and divide it by 3, gives me 2x and 1. Okay? Now, these two brackets will always be the same. If you've chosen the right numbers, they will always be the same. So now I'm going to take this entire expression and I'm going to common factor again. So I'm going to write this over here. Common factor again. And this time, instead of common factoring the parts, I'm common factoring the entire expression. What's in common between this part of the expression and this part of the expression? What's the same about it? Well, they both have a 2x plus 1. So 2x plus 1 becomes my common factor. Okay? So this part of the expression divided by 2x plus 1, so x times 2x plus 1 divided by my greatest common factor, 2x plus 1, leaves me with just x. And 3 times 2x plus 1 divided by 2x plus 1 is just 3. And so now I have factored it. Oops. Now I have factored it. And you see my answer is the same as on the previous board. Okay, it's just another method. So if you're using the area model, it's a visual method, but it's going to require some trial and error, maybe changing your answer because it didn't work out and trying different numbers. This one doesn't require any trial and error as long as you choose the correct pair of numbers. Okay, you'll always get the right factoring at the end. I'm going to show you another method. So again, complex trinomial. This is the crisscross method. Okay, 2x squared plus 7x plus 3. Oh, you know what? Hold on. Yeah, I just wanted to show one thing actually that I forgot to mention. See these parts here of when we chose the two numbers that multiply to AC and add to B? This x and this 6x, I don't know if you caught this. It's the same x and the 6x that's in the area model. Okay, it's the same, right? It works out the same. So I just wanted to mention that because you're about to see the same thing here. Okay, so the crisscross method is also a trial and error method. It goes like this. I'm going to take my 2x squared into what goes into that. So 2x and x, and I'm going to write those two factors of 2x squared underneath. Right? And 3 will be 3 and 1. Those are the factors of 3. Then what I'm going to do is I'm going to multiply crisscross diagonally. Okay, so multiply diagonally and add the product. So I'm going to get 3x, 3 times x is going to be 3x, and then 1 times 2x is going to be 2x, and I'm going to get 5x. That 5x, in order to factor correctly, needs to equal the middle term. Add the products, and that they should equal the middle term. And in this case, it does not. It adds up to 5x when it should have been 7x. So that means that I haven't chosen my numbers correctly. So I'm going to do the same thing that I did with the area model, and I'm going to try a different combination. So again, these numbers are kind of easy. There's not too many options. So instead of 3 and 1, I'll go 1 and 3. And so now when I multiply crisscross, I'm going to get 2x times 3, which is 6x, x times 1, which is x, and that does add up to 7x. So how do I write it out? I'm going to write it across so that my first factor is 2x plus 1. I'm just writing it straight across. And then the second factor is x plus 3. And you see that that's the same answers that we got in all the other methods. Okay, so crisscross, very similar to the area model, except without the areas, without the boxes. It does require some erasing and trial and error. Okay, and speaking of trial and error, here's another one. Trial and error, and the trial and error goes like this. So trial and error, there's no boxes, there's no crisscrossing, it goes like this. Okay, I'm going to factor it as something times something, always, that's what factoring is. 2x squared, how do I get 2x squared? Well, the only way is 2x times x. 3, how do I get a 3? Well, probably 1 and 3 or 3 and 1. That's the only other way. Let's see if we chose correctly. So we'll expand. So you could use FOIL, you could use an area model, whatever you like. 2x times x is 2x squared, that works. 2x times 3 is 6x. 1 times x is 7x. Add that, 1 times x is 1x, add those up, that's already 7x, and then the 1 times 3 is a 3. So I know that that works. And only because I chose the numbers in the right place. If I didn't, I would erase them and choose different combination. So just like the area model, just like crisscross, it's a little bit of a trial and error method. So the advantage of this one is it's got very little writing. The disadvantage of this one is, again, you might choose combinations that don't work and you have to erase and try again. Okay, so each of these methods has its advantages. Last one is that difference of squares, right? X squared minus 36, okay? Using the area model, it was really quick. So x squared here, negative 36 here, x and x. You don't have options here. Some number times itself has to be 36 because if I put like 2 and 18, then when I fill this in, I'm going to have x terms that don't cancel out. Notice there's no middle term here, right? No middle term. So it's like saying my expression is ax squared plus bx plus c. I want two numbers that multiply to AC, but they must add to 0 because there's no middle term. So I want these two adding to 0. The only way that's going to add to 0 is if these two numbers are the same, one's positive, one's negative. Then they'll add to 0. So then that's going to equal to x plus 6 times x minus 6. Right, let's do 9w squared minus 1/4. Aha, I stepped it up. Okay, so here we go. Here's the 9w squared. Here's the 1/4. This has to be 3w and 3w. This has to be 1/2 and 1/2. And, and negative 1/2. And I don't even need to do this multiplication. I don't care because I know that whatever that area is, that's going to be the same area, only negative. So they will cancel out. So that will equal to 3w plus 1/2 times 3w minus 1/2. Okay, and there you go. There's your buffet of factoring methods. So factoring by grouping, common factoring, simple trinomials, complex trinomials, and difference of squares. Thank you. See you soon.